You think speed limits are just for highways? Think again. There's a speed limit built into the fabric of reality itself. 299,792,458 meters per second, the speed of light. And here's what's going to break your brain. You can't break this limit. Not with more fuel, not with better engines, not with infinite energy. The universe itself will stop you. And when you understand why, when you really dig into what Richard Feynman discovered about this cosmic barrier, you're going to realize that everything you think you know about space and time is wrong. Most people just accept it. Einstein said so. Light speed is the limit, case closed. But that's not an answer. That's just repeating words. When you ask why nothing can go faster than light, when you demand to know what's actually stopping you, you discover something so fundamentally strange that it changes how you see reality itself. The speed of light isn't just fast. It's not just the fastest thing we know. It's the structure of the universe. It's woven into space and time in a way that makes going faster literally impossible. Let me show you what I mean. And fair warning, once you see this, once you understand what's really happening, you can never unsee it. Every time you flip a light switch, every time you look at your phone, every time you exist in this universe, you'll remember that you're surrounded by forces and limits that are absolutely mind-bending. Here's where most explanations go wrong. They start with Einstein. They talk about relativity like it's some abstract mathematical theory, but that's backwards. The speed limit was discovered by accident, by people who weren't even looking for it, people who were just trying to figure out how light works. And what they found was so disturbing, so contrary to common sense, that it took decades for anyone to believe it. Let's start with something simple, something everyone thinks they understand. Light travels in straight lines. Light bounces off mirrors. Light bends through lenses. Basic stuff, obvious stuff, except here's what nobody expected. Light always travels at the same speed, always, no matter who measures it, no matter how fast they're moving. And this fact, this one simple observation, destroys everything you think you know about how motion works. Picture this, you're standing still, you shine a flashlight, you measure the speed of the light beam, 299,792,458 meters per second. Fine. Now you get on a train, a fast train, moving at half the speed of light. You shine the flashlight forward in the direction the train is moving. Common sense says the light should now be traveling faster. The speed of light plus the speed of the train. Just like throwing a ball from a moving car makes the ball go faster relative to the ground. But that's not what happens. You measure the light. Still 299,792,458 meters per second. Exactly the same. You think you made a mistake. So you get the train going faster. 90% the speed of light. You shine the flashlight. You measure. Still the same speed. You get frustrated. You push the train to 99.99% light speed. You measure again. Same result. The speed of light never changes. It doesn't add to your speed. It doesn't subtract. It's always the same no matter how fast you're moving. This should shatter your understanding of reality. Speeds don't work this way. In everyday life, speeds add. If you're walking forward on a moving train, your speed relative to the ground is your walking speed plus the train's speed. But light doesn't follow this rule. Light has its own rule, and that rule breaks everything else. Think about what this means. Really think about it. There's something moving through the universe that has a constant speed relative to everyone. No matter how fast you chase it, no matter how fast you run away from it, it always moves at the same speed relative to you. That's not just weird. That's impossible, unless something else is happening, unless the universe is playing tricks on you that are so subtle, so hidden, that you never notice them in everyday life. Here's the trick. And this is where Feynman's genius comes in. Time is not constant. Space is not fixed. When you move faster, time actually slows down for you. Not metaphorically, not approximately, actually. Your clocks tick slower. Your biological processes slow down. The universe literally gives you less time. And distances, they shrink. The space in front of you gets compressed. These aren't optical illusions. These aren't measurement errors. These are real physical changes to the fabric of reality. The universe bends time and space, stretches them, compresses them, does whatever it takes to make sure light always travels at the same speed for everyone. The speed of light isn't just a speed, it's a structural constant. Space and time are arranged specifically to preserve this speed. And here's the beautiful, terrifying part. We've measured this. We've tested it thousands of times. Particles in accelerators, atomic clocks on airplanes, satellites in orbit. The effects are real. Time dilation is real. Length contraction is real. The universe really does warp itself to maintain the speed of light. But that still doesn't answer the big question, why can't you go faster? What happens if you try to break the light barrier? Here's where things get really strange. As you move faster, as you approach light speed, something starts fighting back. It becomes harder to accelerate, much harder. It's not that your engine isn't powerful enough. It's not that you need more fuel. It's that the object itself resists acceleration more and more. We used to call this relativistic mass increase, the idea that things get heavier as they go faster. But that's not quite right. Modern physics explains it differently. Your mass doesn't change, but something else does. The relationship between force and acceleration breaks down. The same push that used to speed you up barely affects you anymore. And as you get closer and closer to light speed, it takes more and more energy to go just a tiny bit faster. The mathematics are brutal. To reach exactly light speed, you would need infinite energy, not a lot of energy, not more energy than exists in the universe. Infinite energy, which is impossible. So nothing with mass can ever reach light speed. The universe won't let you, not because of some arbitrary rule, not because we haven't figured out the right technology, because the structure of space-time itself prevents it. Light can travel at that speed because photons have zero mass, literally zero. Massless particles don't just travel at light speed. They must travel at light speed. They have no choice. They can't slow down. They can't speed up. They're locked at that speed by the laws of physics. But anything with mass, anything you can touch, anything made of atoms, it can get close, very close. 99.9999% of light speed, but never quite there. There's always a gap, always a barrier, always something stopping you at the last moment. Now you might ask why? Why is the universe set up this way? Why is there a speed limit at all? And here's the answer that's going to frustrate you. There isn't a deeper why. The speed of light isn't a speed limit imposed on the universe. It's a consequence of how the universe is built. Space and time aren't separate things. They're woven together into something called space-time. And space-time has a geometry, a structure, and that structure has a built-in conversion factor between space and time. That conversion factor is the speed of light. It's not that light is special. Light just happens to travel at the maximum rate that space-time allows. The rate itself is a property of space-time, not of light. If light didn't exist, the speed limit would still be there. It's baked into the universe itself. It's the maximum rate at which cause and effect can propagate, the maximum speed of information, the maximum rate of change. Here's another way to think about it that will completely rewire your brain. You're always moving through space-time at exactly light speed, always. Right now, sitting still reading this, you're traveling through space-time at 292,458 meters per second. But that motion is divided between space and time. When you're sitting still, all your motion is through time. You're moving into the future at maximum speed, 1 second per second. But when you start moving through space, something has to give. You're stealing motion from the time direction and putting it into the space direction. The faster you move through space, the slower you move through time. It's like you have a fixed budget of motion through space-time, and you can spend it on space or time, but not both at maximum. This is why time slows down when you go fast. This is why distances shrink. You're redistributing your motion through space-time, and there's a limit. If you could somehow move through space at light speed, you would have zero motion left for time. Time would stop for you completely. This is why photons don't experience time. From a photon's perspective, it's created and destroyed in the same instant. No time passes. The entire universe is frozen. You can't go faster than light because you can't have negative motion through time. That's the wall. That's the absolute barrier. You can't undo time. You can't reverse cause and effect. And that brings us to something even more disturbing. If you could somehow break the light speed barrier, if you could go faster, you wouldn't just be moving through space really fast. You'd be moving backwards in time. Let me explain what that means. Imagine you're watching two events happen, event A and then event B, cause and effect, normal stuff. But now imagine someone else is watching the same events while moving very fast relative to you, fast enough to break light speed. From their perspective, they would see event B happen before event A, effect before cause. The universe would be running backwards for them. This isn't science fiction. This isn't speculation. This is what the mathematics of relativity tells us must happen. If faster than light travel were possible, it would allow time travel. You could send a message to yourself in the past. You could affect events that already happened. You could create paradoxes that would tear apart the logical structure of reality itself. The universe protects itself from this chaos by making faster than light travel impossible. The light speed limit isn't just about speed, it's about preserving causality. It's about making sure that cause always comes before effect. It's about keeping the universe logically consistent. Break the speed limit and you break time itself. But here's what really should blow your mind. We've tested this, not the time travel part, obviously, but the effects that lead up to it. Particles and accelerators get pushed to incredible speeds, 99.9999% of light speed. And the closer they get, the harder it becomes to push them faster. Exactly as predicted. The resistance isn't mechanical. It's not friction. It's space-time itself pushing back. GPS satellites have to account for time dilation. They're moving fast and they're in weaker gravity, so time passes differently for them than for us on the ground. If we didn't correct for this, GPS would be off by miles within hours. Your phone's navigation works because we understand that time is flexible. Moons are particles created when cosmic rays hit the atmosphere. They should decay before reaching the ground. Their lifetime is too short, the distance too far, but they do reach the ground. Lots of them, because they're moving so fast that time slows down for them. From their perspective, they live long enough to make the journey. From our perspective, they live longer because time is stretched. Every particle accelerator on Earth confirms these effects daily. Every satellite, every precision clock. The universe really does behave this way. Time really does slow down. Space really does contract. The speed of light really is constant, and nothing really can go faster. Think about the implications. Every force you've ever felt, every push and pull, every contact between objects, it's all electromagnetic. The force that stops your hand when you touch a table is the same force that makes magnets repel. Electrons pushing against electrons with enormous strength. But those electrons can only push on each other at the speed of light. Information about the push can only travel at light speed. So when you touch something, you're not really touching it. You're feeling electromagnetic forces acting across tiny distances at exactly light speed. The solidity of matter is an illusion created by electromagnetic forces that can't propagate faster than light. If those forces could travel instantly, if there were no speed limit, the entire structure of matter would collapse. Atoms couldn't exist. Chemistry couldn't work. Life would be impossible. The speed of light isn't just a cosmic speed limit. It's the thing that makes the universe work. It's the thing that allows stable atoms, consistent physics, logical causality. Without it, without that barrier, without that fundamental limit, there would be no structure, no order, no possibility of existence itself. And here's the most beautiful part. We figured this out. Humans, with our limited senses and brief lifespans, managed to discover this fundamental truth about reality. We built machines that could test it. We developed mathematics that could describe it. We created technology that depends on it. We turned this cosmic truth into GPS navigation and particle accelerators and atomic clocks. That's the real miracle. Not that the universe has these limits, but that we found them. Not that space-time is curved and twisted and strange, but that we measured those curves. Not that reality is far weirder than common sense suggests, but that we had the courage to follow the evidence wherever it led, even when it led to conclusions that shattered our intuitions about how things should work. The speed of light stands as proof that the universe is knowable, that reality follows rules, that those rules can be discovered and tested and used, even when those rules are so far beyond everyday experience that they seem impossible, even when accepting them requires abandoning everything you thought you knew about space and time and motion and causality. So when you ask me why you can't break the light speed barrier, you're really asking me to explain the fundamental architecture of existence itself. And that's exactly what Richard Feynman understood better than almost anyone. He didn't just accept the equations. He didn't just memorize the formulas. He looked deeper. He asked the uncomfortable questions. And what he found was that the speed of light barrier isn't really about light at all. Here's what Feynman realized that most people miss. The barrier exists because space-time itself has a maximum rate of information transfer. Think about what that means. Every cause needs to communicate with its effect. Every force needs to tell distant objects how to behave. Every change in one place needs to propagate to other places. And all of that communication happens at exactly one speed, the speed that we call the speed of light. But here's where it gets really twisted. That communication isn't instantaneous. It takes time, real time. When you push on a wall, your hand doesn't instantly know the wall is there. The electromagnetic forces in your hand have to send signals to the electromagnetic forces in the wall. Those signals travel at light speed. The wall pushes back by sending signals back to your hand, also at light speed. The entire interaction happens through this back and forth communication at exactly 299,192,458 meters per second. Now imagine trying to move faster than that communication speed. You'd be trying to outrun the very signals that tell the universe how to behave. You'd be trying to move faster than cause and effect itself. And that's impossible. Not because some cosmic referee is watching and enforcing rules, but because without that communication, without those signals, there would be no forces, no interactions, no way for anything to affect anything else. The speed of light is the speed at which reality updates itself. It's the refresh rate of the universe. And you can't move faster than the refresh rate because you're part of what's being refreshed. You're part of the system. You can't escape the system by moving faster than the system can handle. Feynman had a way of making this concrete. He'd talk about electrons and how they interact. An electron here pushes on an electron there. But how does the first electron know the second one exists? How does it know which direction to push? The answer is electromagnetic fields. The second electron creates a field that extends through space. That field carries information about the electron's position and charge, and that information travels outward at the speed of light. So when you try to push an electron faster and faster, you're fighting against the very mechanism that allows the pushing to happen in the first place. The electron can only respond to forces as fast as information about those forces can reach it. And that information travels at light speed, no faster. So the electron can never move faster than the signals that control its motion. But there's something even stranger happening. As you push that electron closer and closer to light speed, something weird happens to the energy you're putting in. Most of it stops going into speed. Instead, it goes into what physicists call relativistic energy. The electron becomes harder and harder to accelerate, not because it's getting more massive, but because the relationship between energy and motion breaks down near light speed. So the next time someone asks you why nothing can travel faster than light, don't just say because Einstein said so. Tell them the truth. The speed of light isn't a speed limit. It's the speed at which reality itself operates. It's the rate at which the universe processes existence. And we're not separate from that process. We are that process. Breaking the light barrier isn't just impossible. It's meaningless. Because without that limit, without that fundamental constant, there would be no universe to break rules in.